Hello, hi there, and welcome back. You are watching Middle School Math Tutorials with Dr. K, and I'm so glad you're here. Today, we are talking about combining like terms. We're going to talk about what like terms are, how do you combine them, and this is kind of your lead-in to solving algebraic equations, which is an exciting step in math, moving towards algebraic solving. Let's jump in. So let's talk about like terms first. Let's say I'm sitting in my home and I have a bunch of grapes in the fridge and I have another bunch of grapes in a bowl on my counter. What might you say about the fruit that I have? You might say that I have two bunches of grapes. You can combine those. I own them both. They are mine. I have two bunches. Doesn't matter really where they're sitting in my house. I still have two bunches of grapes. Now let's say on my desk I have 3 apples that I brought to share with some friends, and then in my fridge I have 7 more apples. You might say that altogether I have 10 apples. What you might not say, what you can't say, is that I have 12 things. 12, let's call them grapples, because I have grapes and apples. Those aren't considered like things. They aren't like terms, which means I might talk about my grapes, I might talk about my apples, maybe I say that they are all fruits, but I can't really combine them into one thing because grapes and apples are totally separate things. Algebraically, we're kind of doing the same thing. We're looking for like terms, things that are alike, that have the same variable. Let's look at some examples of what this means in algebra. Here's where we're really going with this. You'll see in example 1 that I've got 2 terms. I've got a negative 3x, and then I've got a plus 6x. Now, those are what we would consider in algebra like terms. It's like saying I have negative 3 apples, maybe I owe somebody 3 apples, and then I also have a positive 6 apples, maybe there are 6 that are in my fridge that I own, and I'm trying to figure out how many apples will I end up with. Now, when you're looking to combine your like terms, you're looking to make sure that you've got the same variable. That's what makes them like terms. So if they both have x's, they're like terms. So what I do to simplify an expression like this is I combine my like terms. And that means I take the coefficients, which are the numbers in front of the variable, and I combine those using my integer rules, maybe my decimal rules or fraction rules if that's what those numbers are. In this case, they're integers. And I'll combine them using addition because that's what I see in the problem. So I will combine negative 3 plus 6 to get a positive 3. And then when I'm combining like terms, you'll notice that the variable is just kind of along for the ride. So I had negative 3x's, and then I added to it 6x's, and so the result is a positive 3 still x. My variable has not changed. It has not morphed in any way. Kind of like if I added my 2 apples plus my 7 apples, I now have 9 apples. That thing that I'm adding has not changed. So my x has not changed in any way. I'm just figuring out how many x's I have. Now in example 2, it's the same process. I'm looking to see that I have like terms. In this case, they're y's, they're not x's, but they're still like terms because they both have a y. So what I'm really going to tune into are the coefficients for those y's, the negative 12 and the 7. Now, when it comes to adding like terms or subtracting like terms or combining in general like terms, remember, you're going to look at the sign in front of each number. So the 12 is obviously negative. I can see that. And then the 7 has a plus in front of it. So what I'm doing is taking negative 12 and I'm adding 7. Negative 12 plus 7, I know, is negative 5. And then remember, if I'm adding negative 12 y's and 7 y's, what I end up with is negative 5 y's. The variable does not change. So this is an example where we're really testing our knowledge of like terms. You'll notice that I have 6m minus 14 plus 12m, and only 2 of those things have m's, which means 2 of those terms are like terms, the other is not. So when you're combining like terms, you're doing just that. You're only combining the things that are like terms. I like to box or circle the things that are like terms just to give me a focal point for what it is that I'm dealing with. Now, again, we need to look at the sign in front of each number. The 6m has nothing in front of it, so we can assume it's positive. The 12m has a plus in front of it, which tells me that I am adding that 12m. 6m plus 12m will give me, as I know, 18m. But what do I do with that minus 14? If there's a term that has no other like terms, it's just going to kind of hang out and be a part of the answer. So the minus 14 is just going to come down into my answer. And this, in fact, is my final solution for this problem. And that feels strange. We're used to in math getting one number as our answer. When you're simplifying an expression and you're combining your like terms, you should get a simplified expression, but you might not get a one number answer. What you're looking for is the fact that I had 3 terms and now I have 2 terms. That means I've done my job. I have simplified. This is, in fact, my final answer. Here's another example where, again, we're getting a little more challenging. I'm seeing 4 terms this time instead of 2. What I'm noticing is that 2 of my terms have a variable and they have the exact same variable. That makes those like terms, those 2 pieces that have an x. I'm also noticing that I have 2 pieces that have no variables. Those are considered like terms too. So I'm looking for all of my groups of like terms. Now let's deal with those x's first, my variable. Again, I need to look for the sign in front of each number. The 1.3 is positive. The 6.2 has a minus in front of it. So what I really need to solve is 1.3x minus 6.2x. I remember from my decimal rules that when I'm dealing with positives and negatives, I'm allowed to switch those around and subtract 1.3 from 6.2 as long as I line up my decimal, first of all, and then in the end, I have to remember whether it should be a positive or negative. Now, when I subtract and I line up my decimal, this does involve some borrowing, but otherwise becomes a relatively easy example to subtract. Now, 6.2 minus 1.3 is 4.9, but 1.3 minus 6.2, the other way around, will give me a negative 4.9x. Lucky for us, those constants, the numbers that don't have a variable, those are called constants. Those aren't decimals, those are just whole numbers actually, so they're relatively easy to work with. I'll look for the sign in front of each. I see that the 4 has a plus in front of it, which means we can think of it as a positive 4. I also see that the 2 has a plus in front of it, so I need positive 4 plus 2, which of course is 6. I'll write that as plus 6. Now remember, our job here is not to get a final answer. We might not get a one number answer, but we are looking to get a simplified answer. I started this problem with 4 terms, and now you can see in my final answer I have 2 terms. So although it doesn't feel like an answer, the answer is not 5 or negative 12 or 3.8. It is, in fact, a final answer when it comes to combining like terms. We have simplified our expression and we have combined anything that was considered a like term. For our last example today, I wanted to show you one that involves fractions, just because fractions can be kind of complicated and intimidating. So I'm still going to look for my like terms. I have 2 terms that have a y, that makes those like terms. And then I see that I have 2 constants. Those are the terms without a variable. So I can kind of identify with my circling and my boxing what things I need to combine. Now, we'll start with those fractions just to get that out of the way. I see that I have negative 5/8 y, and then I see that I have plus 2/3 y. And I know from my fraction rules that I need common denominators if I'm going to add or subtract fractions. Now, 8 and 4 both go into 24, so I'm going to change both of those denominators to 24. You'll notice that my variable does not change. It's really just, we're treating this just like a fraction problem. And if I change the denominator, I have to change the numerator. So 8 times 3 is what gave me 24, so I need to do negative 5 times 3 to get negative 15. On the second fraction, 3 times 8 gave me 24, so 2 times 8 gives me 16. Once I've gotten common denominators, I can now add these 2 fractions together. I have negative 15 24ths of y, and I have plus 16 24ths of y. And what's fun about fractions is once you get the common denominator, you're really following integer rules. So I know I have negative 16, and I'm going to add 16. Negative 15 plus 16 is positive 1, so I get 1/24 of y. Again, we've got an example where our constants are much easier to work with. So I'm going to look at the sign in front of each. I see that I have a plus 4, so I can think of that as a positive 4. And then I have a minus 9, so I'll take away 9 from my positive 4, which leaves me with a negative 5. Now, when I rewrite that in my expression, instead of writing plus negative 5, I'm going to change it, simplify it to just minus 5. When you're looking at expressions, one thing you should know is that the difference between a negative and a minus is a little nebulous. A negative and a minus can be used interchangeably. So instead of writing plus -5, I wrote -5. They mean the same thing. All right, now I have my final answer, and I'm going to go ahead and box it here. Remember that we are simplifying the expression, so it's okay that it's not a one-number answer. We've done our job. We have combined like terms, and we have simplified this expression. We will get to the part where we actually solve for the variable, but in this video, we're not there yet. We're really just looking to simplify. Okay, so we just looked at 5 examples in varying difficulties on combining like terms. So remember, your job is fairly simple. Find the things that are considered like terms. They have to have the same variable. So x's and y's cannot be combined. X's and x's can be combined. It sometimes helps to also rewrite subtraction using the additive inverse. I didn't show that in this video because I've showed it in other videos, but for example, if I had 9x minus 12x, I might rewrite that as an addition problem using the additive inverse of 12, which is its opposite, negative 12x. That kind of helps me to see that I'm taking a 9x and I'm adding a negative 12x, which would leave me at negative 3x. So I added that as a tip here. Use it if you like it. Don't if you're really comfortable with your integer rules, but it might be helpful. Once you have found your like terms, maybe you've boxed some, circled others, changed colors, whatever it is, you've got to combine the like terms. And remember, no grapples allowed. You can't combine things that are not like terms. Grapes and apples are completely separate. X's and Y's are completely separate. That's why we really focus on what are the like terms, and then that's also why we sometimes circle the ones that are alike and then box the other ones that are alike, all to make sure that we're not combining things that are not like terms. Anyway, this will give you a start on combining like terms. There's a lot you can do from here, and I know you've got this. Once again, thanks for being here at Middle School Math with Dr. K. I'll see you next time. Have a great day.